Hello everyone, welcome back to my channel. So today we will be discussing on NBA Tier 1 aspects as per the new format, which is not a complex topic, but the name of the topic is complex engineering problem, its necessity and how do we connect it with respect to outcome-based education and outcome-based curriculum. So before we head into the realm of complex engineering problem, let us understand why this idea of complex engineering problem has come into existence and how engineers are going to play a very prominent role with respect to building up a very sustainable world altogether and also to solve various new problems related to society, related to environment, related to humankind, related to water or related to anything. So how do we combine all these together and how an engineer is going to play a very prominent role in all these aspects is what we will understand first and then jump into what a complex engineering problem is, how it is being interconnected with respect to program outcomes, and what are knowledge profiles and how do engineering activities combine with this and all this together, how it leads to a professional competency of an engineer. So engineering is an activity that is essential to meeting the needs of people, economic development, and the provision of service to the society. Engineering involves the purposeful application of mathematical and natural sciences and a body of engineering knowledge, technology, and techniques. Engineering seeks to produce solutions of which effects are predicted to the greatest degree possible in often uncertain conditions. So, whatever may be the condition, an engineer is going to provide a solution for such aspects. While bringing benefits, engineering activity has potential adverse consequences as well. So, engineering therefore must be carried out responsibly and ethically, use available resources efficiently, be economic, safeguard health and safety, be environmentally sound and sustainable, and generally manage risk throughout the entire life cycle of a system. So all these responsibility have been laid out on engineers across the globe. So in a recent meeting of United Nations Sustainable Development Goals, the target has been set for 2030 for engineers to play a vital role in contributing for making progress towards the goals that have been set by United Nations to make this world a sustainable living place for the generations to come forward. Typical engineering activity requires several roles, including those of engineer, engineering technologist, and engineer technician, right? So, three aspects or three categories of jurisdictions have been where one category follows engineering as a professional engineers, then engineering technologist, and engineering technician. The development of an engineering professional in any of these categories is an ongoing process with important identified stages. The first stage is attainment of an accredited education qualification. So that is the first and the primary aspect with respect to engineering education. So in this first stage, the graduate stage, the fundamental purpose of engineering education is to build a knowledge base and attributes to enable the graduates to continue learning and to proceed to formative development that will develop the competencies required for independent practice. So that is a base level in what an engineer is expected to do in stage one with respect to all the three jurisdictions. The second stage, following a period of formative development, is a professional registration stage. So, in this, the fundamental purpose of formative development is to build on the educational base to develop the competencies required for independent practice, in which a graduate works with engineering practitioners and progresses from an assisting role to taking more individual and team responsibility until competency can be demonstrated at a level required for registration. Once registered, a practitioner must maintain and expand these competencies. The third stage, along with these two stages, an engineer or an engineer technologist or an engineer technicians should have a third quality or a third milestone, that is to qualify for international register held by various jurisdictions. In addition to all these, an engineer or a technologist or a technician are expected to maintain and enhance competencies throughout their working lives. So it is a lifelong learning process where we have to keep on improving ourselves as engineers. So several international accords provide for recognition of graduates of accredited programs of each signatory by the remaining signatories. So there are basically three signatories present. One is the Washington Accord, the Sydney Accord, and the Dublin Accord. So the Washington Accord provides for mutual recognition of programs accredited for the engineer track. The Sydney Accord establishes mutual recognition of accredited qualification for engineering technologists, and the Dublin Accord provides for mutual recognition of accredited qualifications for engineering technicians. So these accords are based on the principle of substantial equivalence rather than exact correspondence of content and outcomes. Similarly, the International Professional Engineer Agreements, the International Engineer Technologies Agreement, and the Agreement of International Engineering Technicians provide mechanisms to support the recognition of professionally registered in one signatory jurisdiction obtaining recognition in the another. So they are mutually consent towards obtaining the recognition from one jurisdictions to another jurisdictions. Now, with understanding what an engineer is, what are the expectations of an engineer, and what the goals have to be achieved as an engineer with respect to sustainable development goals laid out by UN by 2030, we have to define our engineering curriculum in such a way we reach all these aspects to make this world a better place to live in, right? So for all these aspects, the frameworks have been devised, and in India, we follow Washington Accord, governed by National Board of Accreditation, which defines the roles and responsibilities of an engineering education of how it has to be to meet the level of Tier 1 or Tier 2 accreditation. So most of the institutes in India are moving towards Tier 1. They are getting the autonomy, and most of the universities are in the category of Tier 1. So any institutes which function under a gambit of a prime university fall under the category of Tier 2 process. So in either of the process, a program outcome is a primary aspect where a curriculum has to be developed keeping in mind these aspects. Along with it, professional competencies have to be considered, work knowledge attributes have to be taken into consideration, and also complex engineering problems and engineering activities have to be kept in mind. So program outcomes are they form a set of individually accessible outcomes that are components indicative of graduates' potential to acquire competency to practice at an appropriate level. So, attaining these program outcomes will finally lead to having the achievement of professional competencies. The program outcomes are exemplars of the outcomes expected of graduate from an accredited program. So the program outcomes are intended to assist signatories and professional members to develop or review their outcome-based accreditation criteria for use by the respective jurisdictions. So the program outcomes are assessable outcomes supported by level statements developed by the signatories that give confidence that the educational objectives of the programs are being achieved. So these program outcomes are well defined, and under NBA we have in new format 11 program outcomes. So these program outcomes are clear, succinct statements of expected capability, qualified if necessary by a range of indication appropriate to the type of the program. Program outcomes are also known as graduate attributes, which are defined for educational qualification in engineering technology and engineering technician tracks. So for each attributes, the statements are formulated for all the three tracks using a common stem with ranging information appropriate to each educational track. So the quality of the program depend not only on the stated objective and attributes to be assessed, but also on the program design, resource committed to the program, the teaching and learning process, and the assessment of students, including confirmation that the program outcomes are satisfied. So program outcomes are just laid out statements with thorough inspection, which are clear and easily understood on how a curriculum has to be framed and how to attain these with respect to various activities. So these are the statements which have to be achieved with respect to development of program in such a way that the design, the resource, and the teaching and learning process have to come together to meet the required goal. So the program outcomes are organized using 11 headings as per the new SIR format, which is being rolled out by NBA India. So for example, for an engineering attribute, the common stem is going to be applied knowledge of mathematics, natural science, computing, engineering fundamentals, and an engineering specialization. So in all the three tracks, as we discussed earlier, engineer, engineering technician, and engineering technologist, so all have a common stem. So these common stem are taken and then rewritten the statements of program outcomes or graduate attributes with respect to particular jurisdictions. So in engineer graduate, you see how the statement has been framed. Apply knowledge of mathematics, science, computing, and engineering fundamentals, and an engineering specialization as specified in WK1 to WK4, which is knowledge attitude profile 1 to 4. These statements are again given with respect to NBA in India to develop solutions to complex engineering problems. So this word is a major focus with respect to engineer graduate, that is complex engineering problems. So why do we do all this? Apply all these aspects to solve complex engineering problems. Keeping in mind, we achieve the work knowledge attitudes with respect to WK1 to WK4. Whereas engineering technologist graduate apply the knowledge of mathematics, science, computing, and engineering fundamentals and an engineering specialization as specified. This is SK Sydney Accord Knowledge Profile 1 to 4 respectively to define and applied engineering procedures, processes, systems, or methodologies. So they don't have a word known as complex engineering problem with respect to Sydney Accord. Similarly, if you look at an engineering technician graduate, apply knowledge of mathematics, science, engineering fundamentals, and an engineering specialization as specified in Dublin Accord, knowledge attitude profile 1 to 4, respectively to wide practical procedures and practices. So this is a wide engineering problem, this is a complex engineering problem, and this is a broad engineering problem. So all three aspects have a common stem. The statements are going to vary depending upon the jurisdictions of which they are going to define the statements. The outcomes of accord programs are defined as knowledge profile, which is an indicated volume of learning and the outcomes against which graduate must be able to perform. So before we finalize our curriculum or develop our curriculum, we have to keep in mind about these knowledge profiles. These knowledge profiles are going to be reflected in the program outcomes. So the program outcomes, when we map it to the course outcomes, should have the aspects with respect to our TLP process, with respect to the data that we have, it covers these knowledge profiles. So when we map all these, finally it leads to the professional competency of a student who is going to be graduating out with respect to accredited program. The requirements are stated without to the design of programs that would achieve the requirements. So here a program is not kept in mind and the statements are developed. These statements are broadly defined with respect to various jurisdictions, and there is a free hand to develop your curriculum with respect to these defined statements. The providers or the developers or the program coordinators therefore are free to design programs with different detailed structure, learning pathways, and mode of delivery. A complete autonomy is given to the developer on how we understand these knowledge profile, program outcomes, knowledge attitude profiles, complex engineering problems, engineering activities, and professional competencies. So now what is this professional competency? So professional competency or occupationally competent person has the attributes necessary to perform the activities within the profession or occupation to the standards expected in independent employment or practice. So professional competency profiles for each professional category record the elements of competency necessary for performance that the professional is expected to be able to demonstrate in a holistic way at the stage of attaining registration. So each profile of these competencies consists of 13 elements. So different categories of professional competencies have been developed and they are 13 in number. Individual elements are formulated around differentiating characteristics using a stem and modifier, similar to the method used for program outcomes under three different jurisdictions. Professional competencies can be described using a set of attributes corresponding largely to the program outcomes but with different emphasis. So, for example, how this professional competency vary is you can look over here. A professional at a professional level, the ability to take responsibility in real life situation is essential, right? So, when a graduate is graduated from a program and once he is into the real world, he is bound to take the responsibility of real life situation. So unlike program outcome, professional competency is more than a set of outcome that can be demonstrated individually. Rather, competencies must be assessed holistically. So that is the primary aspect of professional competency. The professional competency profiles are written for each of the three categories of jurisdictions, that is engineer, engineering technologist, and engineering technicians at the point of registration. So our next focus is going to be only with respect to complex engineering problem, that is professional engineer under Washington Accord, for which and National Board of Accreditation India follows. So there uh, the definition of complex engineering problem has been well defined with respect to Washington Accord, that is engineering jurisdiction. Then here it is with Sydney Accord and this is with Dublin Accord. So if you look at the statements, the complex engineering problem is focusing on Washington Accord. Broadly defined engineering problems focusing on Sydney Accord, and well-defined engineering problem is focusing on Dublin Accord. So if you want to know what is a complex engineering problem and how do we define it, the definition of this complex engineering problem is clearly stated over here. So complex engineering problems have characteristics of WP1 and some or all WP2 to WP7. So WP wherever you see with respect to the new SAR, it is a complex engineering problem 1 to 7 statements. So WP1 is the complex engineering problem characteristics of WP1. It means it cannot be resolved without in-depth engineering knowledge at the level of one or more of WK3, WK4, 5, 6 or 8. So this is in turn getting connected to knowledge profiles. Okay, knowledge attitude profile. This is getting connected. So WP1, it cannot be solved without in-depth engineering knowledge at the level of one or more. So all these knowledge attitude profiles have to be combined together to solve a complex engineering problem, which allows a fundamentals based first principles analytical approach. So complex engineering problem characteristics of this, or including some of these parts from WP2 to WP7 with WP1, or WP2 to WP7, everything can be included in a complex engineering problem. So if you look at an attributes, so you can see over here, it should have a range of conflicting requirements with respect to WP2. It means involve wide ranging and or conflicting technical, non-technical issues such as ethical, sustainability, legal, political, economic, societal, and consideration of future requirements. In WP3, third level or the third definition or the third criteria for complex engineering problem have no obvious solution. So there is no particular solution. The textbook problems or the solved examples or the numericals at the end of the textbooks cannot be categorized into complex engineering problem until and unless those problems have these attributes involved in them. So it should have a creativity and originality in analysis to formulate suitable models. So familiarity of the issues is another attribute which involve infrequently encountered issues or novel problems. WP5 address problems not encompassed by standards and codes of practice of professional engineering. Involve collaboration across engineering disciplines, other fields, and a diverse group of stakeholders with widely varying needs. So interdisciplinary is going to play a very major role with respect to complex engineering problem. Address high level problems with many competencies or sub problems that may require a system approach. Okay, so these are all the characteristics of a complex engineering problem. So when we are defining the complex engineering problem, we should keep in mind that all these aspects or of these aspects will be covered with respect to those problem statements. So we will not focus on this broadly engineering problems or well-defined engineering problems, but because we are more interested in complex engineering problems. So if you go through these statements once or twice, then you would get a clear picture of how do you frame a complex engineering problem with respect to the course that is being assigned to you in a program. So next, if you look at this, the program outcomes which are defined 11 in number, PO1 to PO6 has the word complex engineering problem in it. Okay, so if you look at PO1 to PON, among that, PO1 to PO6 has the word complex engineering problem defined in those POs. So, and these PO1 to PO6 have to address WP1 and some or all of WP2 to WP7. So once you are addressing and PO1 to PO6 will also have an encompassment of knowledge and attitude profiles, which are statements from WK1 to WK9, except for WK8. So 8 statements of knowledge and attitude profiles will fall in complex engineering problems, which are in turn connected from PO1 to PO6. So when you're defining your course outcome and mapping it for any of the POs, either from PO1 to PO6, you have to keep in mind that you need to show the outcome or the mapping of articulation matrix of CO and PO. If it is mapped from PO1 to PO6, then you need to design your delivery strategies, teaching learning process, and various aspects so that it includes what a complex engineering problem is. Okay, so complex engineering problem has to be included wherever you're mapping a course from PO1 to PO6. So then your mapping with respect to course outcomes, program outcomes will be completely satisfied if you attribute all these aspects with respect to complex engineering problems, which in turn covers the knowledge and attitude profiles. So this is a brief first part of discussion with respect to complex engineering problems. In the coming discussion, we will have the discussion on what are engineering activities and what are professional competencies that we intend to achieve as a whole once the program is completed for a graduate. Okay, thank you. See you next time.